I'm going to share my screen. Here you go. So I'm going to discuss question number 4 and 5, okay, in this video. So let's see the first question number 4. It gives you the derivatives of 3 functions and asks you to find the critical points where the function increasing and decreasing the open intervals, and what point, if any, does f assume local max and mean. Okay. Uh, so you will get a very similar question like that. Probably you can choose 2 questions out of 3. If you don't like trick question, you can, skip it. Or if you prefer to, take the challenge, it's totally up to you which question you can try. Okay. But let's see in general how, do this type of question when you are given the first derivative. Okay, so you set the first derivative equal to 0 to get the critical points. And if you see this function, it's pretty easy to get the critical points, which is 7, -1, and -5. So I set each factor equal to 0 and get those 3 critical points. Okay, and that's part A. Part B, to find where the function increasing or decreasing. So I can write down my number line and mark all the points starting from -5 here. This is -1, approximately 7 is greater than that. Right now you choose numbers, um, you know, within each intervals. For an example, let me choose a different color if I can. Yeah, I like this one here. So like x equal -6. Here you can choose something like -2. Here you can choose 0 maybe. Here you can use 8. So I can use those 4 numbers to discuss what happened in each 4 intervals. Okay. But what I'm going to do is I plug that numbers back to the first derivative and take the sign plus minus value of the first derivative. For an example, if I use -6 and plug to my first factor, I get a minus number. So if you need the value, it will be -13. I don't need to write the number. I just write the sign of the number, -13. The second factor also negative. Third factor also negative. So it's like 3 products of negative numbers. So it will be negative. So that means original function is decreasing, right? So you can write on -infinity to -5, function is decreasing. F is decreasing. Maybe there are some other intervals it will be decreasing. So if there's some other intervals, I'm going to include them using my union notation. Union means you include all the others. So let me plug -2 back to the function. So can I erase? Let me see. Can't use the eraser, but it's okay. If you plug -2, you get a minus number. Here also minus, but this one gives me plus. So it's basically plus. That means in between -5 to -1, function is increasing. So I can write on -5 to -1, f is increasing. So I'm going to plug another one. How about if you plug 0 here? Negative, positive, positive. It's overall negative, so it decreases. If you plug 8, so it's plus, all are pluses. So it's a positive. So I got another decreasing part, which is -1 to 7. Increasing from 8 to infinity. So those are the 4 intervals. 2 of them will be decreasing intervals. The other 2 will be increasing intervals. Okay. Let me see. So now you know the part C asks where the local max and mean occur. So these are the critical points. So I'm going to circle them. So you have decreasing and increasing. So x equal minus 5. At x equal minus 5, f has local minimum. Here increase into decreasing, it's a maximum. Here at 7, you have a minimum as well. At x equal minus 5 and 7, local minimum. At x equal minus 1, f has local maximum. Okay. So you answer to all three questions, part A, B, C. For first one, okay? So how do you do part B? Give a little time for you to. So you can try part B, f dash. Okay. Mm, let's see if I can erase them, or I can use a different paper. Okay, so here you go. But I don't need all of them. I'm gonna quickly erase them, okay? Right. So the next one is f dash given as a rational function, but you can quickly get the critical points by uh, setting the numerator equal to 0. Yeah, I think it should work now. Part A. Okay. All right. All right. I think it should. So part A. Part B, actually, question number B we are working on. Okay. So for part A, for question number B, critical points are 2 and minus 2. I just look at the numerator, okay, and got those values. Part B, you need to discuss um, what happened. 4, 2, you can think, okay, I'm gonna plug minus 5 here, like 1 maybe, here 3. If I plug minus 5 for an example, I get first factor minus. Oh, one more thing I forgot. So let me include my minus 1 and 3 as well. Okay, so I'm going to include all those. Of course, they are not critical point, but it might change your first derivative, sign of your first derivative. So I'm going to choose minus 1. It's somewhere here. Minus 1 and 3. Okay. At those point, your first derivative does not exist. At those point, you have vertical tangent lines, but it's not in. You cannot you don't need to plug them because they clearly say it's not domain of the first derivative function. Okay, so plug the -5, plug somewhere something here like -2, here something like 0 maybe. This is 2.5 and like 4. Okay, so I carefully plug and I'll show you what's going on. Okay, so like -5, if you plug -5 here, so it's -5 also give minus in the top. Down -5 gives both factors minus. So overall, it's positive. First derivative is positive. So if you plug point like -2, so you get minus here plus, -2 gives me minus, minus. So overall negative. Okay, these are the points. Careful, okay? Somewhat marking those. Yes, in between that. So what if I plug like 0? If I plug 0, I get negative. Let me be very careful. Okay, so if I plug, for example, -2, I negative, positive, negative, negative. So overall, negative. Yeah, that's right. So if I plug 0 plus here, plus here, minus here. I'm getting the sign, the plus minus of each factors by plugging 0. It's overall positive. 2.5, if you plug 2.5, it's plus in the first, because this gives me plus 0.5, right? This is plus 2.5 plus, and 2.5 minus 3 is negative. So this is negative. If you plug something greater than 4, it will definitely positive. Okay. So at -5, increase into decrease, it's a local minimum. This is, oh, it's again local. So local maximum, both are local maximums. Okay. At -4 and 2, we have local mix. Other points we don't need to talk about. Okay. Because at those points, the derivative does not exist. Right. You can write down the interval of increasing, decreasing, similarly what we did in part A. Okay. Part C, the question number C, it's a trig function. So in this question, it's really a tricky question, part C. The critical points you can get by setting the first factor equal to 0, which is sin x equal 1. It happened when x equal 5. That's the only angle. Remember sine function, it would look like this. The only situation it's become 1 when x equal 5 or 0 to 5, right? Repeat. The other one is 2 cosine x plus 1, 0, which is cosine x equal -half. There are two such angles in the second quadrant and third quadrant. It's 120 degree, which is 2 pi over 3, and 4 pi over 3, which is 240 degree. At 120, cosine 120 is -half, cosine 240 also -half. There are two such angles. Okay. If you remember the unit circle, you will definitely. Pi over 2 is here, 90 degree. This is 120. This is 200 and somewhere there. 4 5 over 3, which is 240. So these are the critical. Right. Now you have to think about what's going on in this function. Okay. We look at the first factor. So my sin x, no matter what, it's always less than 1. So my first factor is always negative, okay? Because I get always sign value here, something less than 1. So it's like half, 1 or root 3 over 2 or whatever. The maximum value I can get is 1 when at this point. But other than that, any point between 0 to 2 pi, if you choose any angle, sine x is always less than 1. So if you subtract something smaller than 1 from 1, so it's always negative. Okay? Second factor is the really important. It's changed the sign which intervals. Okay. So if you plug like this is 90 degrees. So if you plug like 60 degrees, cosine 60 is half. So if you put half here, it's like cancel out, but it's positive. So this is overall the first derivative is negative. Right? So I leave this one for a while. Let me go with the other ones. If you plug like this is 120, this is somewhere here I can choose 180. Cosine 180 is negative 1. So it's like negative now. So it's like negative always the first factor. The other one is also negative. So this is negative. So here somewhere here I can choose. This is again 240. So I can choose 270 for my x here greater than that. If you so always first factor is negative. Cosine 270 is 0. So it's like 1. So it's positive. So this is positive. The reason I leave this part, it's really tricky to get that one because you need to plug something like 100 degree because you don't know exactly what is cosine 100, but I will explain. The first factor is negative. The first factor is negative. Cosine, when the angle increase, the value decrease, okay? Which means you can see like at 120, it's minus half. So let me write it here. Let me explain it here. Cosine 120 means like 2 pi over 3. At this point, you get minus half. Okay? Cosine, for an example, 180, it will be minus 1. You can see when the angle increase, value is decreasing because minus half is smaller than. If you choose something like cosine 90, here, it's 0. Cosine 100, to assume, I don't know exactly value, but it's somewhere in between 0 and minus half. So it's less than minus half, greater than minus half. Sorry. If these numbers are increasing in this way, angles are increasing when you go down. Okay. So I want to say it's something like 1 over 3. This is 0.5 negative. This is 0.3. Negative 0.3 is greater than negative 0.5. So cosine 100 is somewhere here. So you can see the first factor of my function, if you think always negative. The second factor, it's like 0.3 over 2 plus 1. So this is really a positive one. Yeah. I'm sorry, this is 2 down, slightly. Argument is still correct. If you have negative 5 here, you get 0 for entire factor. But if you get anything greater than negative 5, like 0.3, this number is, the product is less than 1. course, it's negative 0.6. It's overall positive. Overall, the value is in. So now you know where the function is decreasing. It's decreasing from 0 to 2 pi over 3 because it's decreasing for entire region here. Actually, 0 to 4 pi over 3. Okay, 0 to 4 pi over 3 and greater than 4 pi over 3, it's increasing. Okay. And it has only one local minimum that happened at this point. Okay. That's how we should discuss that. Okay. I think it's first you set each factor to 0, find out the critical points, and discuss what happened. Because of the trig, it's a little tricky because sometimes you have to really argue and you need to know exactly the values and how it's changed. Okay, right. In the test, I'm gonna put. I will not ask you trig question to curve, probably a polynomial function. Okay, because of the limited time you have. A question like number 1. Okay, let's see how to do question part A. Okay, uh, part A. You take the first derivative. It's negative 9, 12x, 3x to the power 2. Okay. I can take negative 3 out. It's x to the power 2. It's a plus 5, 4x. And you have plus 3. Yeah. You can take negative 3 out. X plus 3 and x plus 3. Okay. I think it's very clear. Okay. So critical points are negative 3 and negative 1. I can take the second derivative easily because it's a polynomial function. It's 12x minus 6x. In the derivative. If I take minus x out, it's 2x plus 1. Okay. I can plug the points like negative 3 to the function, and I know it's positive because this will be negative and times negative. If I plug negative 1, it will be it's again positive. Yeah, it's again positive. So both at minus 3 and minus 1, we have minimums. Okay. Yeah. So I double check this by mistake. Okay. I think it's everything good. Okay. Minus 1, yeah. That's the first derivative. We can take the second derivative, yeah. Here you go, yeah. So both gives me positive. Yeah. Right. So now I can draw the graph roughly. So let me show you how to draw it. But I know one more thing I forgot to tell you. So second derivative will be equal to 0 at x equal minus r. At that point, I'll get I'll get an inflection point. So remember, when you do graphing, you really need to find what happened at each. For example, if you choose the y, you better choose as f, fx. It's easy to plug -1. If you plug -1 for this, you will get 1 plus 27. This is 6 again. This is plus 1. Okay. I just plug -1 back to the function. Oops. How do I get? Okay. So I get, let me see. Oh, Is a color maybe? Let me see. Oh, all right, I'm gonna plug -1. I think I made a mistake, so it's between +9 and -6 and +1. It will give me 5. Yeah, 5. And f of -3 will give me +27. So it's like 6 times 9 -54. And I have -3 times 0 +27. Oh, it's like just 1. Okay. So I got those points, -1, 5, -3, 1. So I know my y-intercept is 1. So it's here, 1. And I know my minimums -3 and -1. I'm going to mark -1 here. Maybe let me get a little space. Okay, -1 here, -3 maybe here. -12 is also important. So I know cube graph, this is -x cube. It's x cube graph look like, that's how the end behavior look like. -x cube look like that. So it's basically at -3, what is the value we got? At -3, it's 1. At -1, 5, right? This is the point. -1, I have 5. Let me see. At -1, what's derivative? It's positive, right? Second derivative is positive. Hmm. Both points is positive. That's interesting. That means both has maximum. I'm really at -12. I didn't find what happened at -12. If I plug -12, it's really much work. Okay, so 9/2. If I plug -12, it will be 6/4. -12 will be 1/8. So this is roughly 8. This is 4 times 9 is 36. This is 44, 32, 33/8. Roughly, it's more than 4. Okay, this is I know 5. Okay. This is concavity change point. This is like 4 point something. Somewhere here, maybe we can say something. This is actually 33/8. Okay, this concavity change. You can plug that. For an example, if you plug -half, the second derivative is 0, right? So that's why it's okay. But I know this is a maximum, so it's going like this. So you can concave down to concave up. But I have really a problem like what happened minus at -1. Let's see if I make a mistake. I take the first derivative. Negative 12x. Okay, that's right. I'm gonna take that. And the first derivative is right. Second derivative also fine. Negative 6. Oh, I see. I'm sorry. This is really stupid. Okay, so let me see. Um, so this is this 12, right? Yeah. Okay. 12x and this is negative 6x. It's really negative 6 times 2 plus x. So this is minus 2. It's my, yeah, I can reduce a lot of work. Okay. So, sorry about that. Oh, yes. Been, video videos like couple of videos back to back. So get a little tired. Okay, so I think this is negative 2. Okay, so negative 2 is the inflection point. No, that's why I was really worried because it's not. So let me see. I know negative 3 and negative 1 is good, but I want to really see whether plus minus. Okay, so I'm going to plug negative 3. If you plug negative 3 here, it's of course it's a positive. If you plug negative 1, it's negative. So negative 1 is a maximum. Yeah, here you go. Oops. Oops. Negative 1. Negative 1 is a maximum. I can see that here, but this is a minimum. Okay? You can clearly see this is a minimum. So you can go in like this is going forward like that. And concavity change point is not minus half. Okay? It's at minus 2 somewhere here. We can find that point by plugging it here, minus 2. If I plug minus 2, it will be 1 plus 18. 4 times 6 is 24. 8. Is it plus 8? Yes. 26, 23. Okay, I got 3. This is not. This is not. So at minus 2, I get 3. Okay. So this is the concavity change. Concave down, concave down, concave down. And at minus 2, it's become, oops, concave up. Concave. Table. It's coming to this point. This is the point of map. Mean point is negative 3, 3. Inflection point is negative 2, 3. That is 3 and 7. That's really cool. Like minus, let me see. At minus 3 also I get, oh, I get 1. Sorry, this is 1. Yeah, that's right. Minus 3, 1. Otherwise, this is inflection. Right, here, that's pretty clear. This is 3. This is here. All right. Okay, so if you have a question about how to draw B and C, please reach out to me. The reason I'm not going to discuss it because there will be no rational function or trig function drawing in this test. If you are interested in how to do it, and if you try and if you feel like you need help, please reach out to me. I'm happy to discuss that. All right. Have a good one. Good.